All right, in this video here, we're going to be talking about 4.6, which is the conclusion of chapter 6. It's going to be mathematical models. Basically, what this is all about, there's not many notes in the section, just examples. It's basically just coming up with equations that would solve a real world type of equation. And then some of the questions do ask you to solve certain types given the information. So I'm just going to kind of pull some questions from the book that looks pretty similar to what you'll be seeing. And then this one will actually be a little bit calculator heavy. And of course, I'll try to teach it without a calculator to help you out, understand the concepts better. But there's just some things a calculator just makes life so much easier to do. And I just want to see what you all see. Okay, perfect. All right. Calculator will come up when we're ready. So let's leave that down for now. All right. All right, so here we go. So again, 4.6 mathematical models. All right, so looking at question one, I actually just wanted to do 1C, but the issue is I have to do 1A to be able to solve for 1C. But you are asked in this one, it says a tinsmith wants to make a small window sill. Make sure everything's working. Okay, go. A window sill planter from a 20 by 60 centimeter sheet of copper. So here is your sheet of copper. This is we'll call 60, and this is 20. She'll form it by cutting equally sized squares. So if you've been in Algebra 2 before, you've probably seen this problem before. At least that's how I always present it to them. And it says that they're all equally sized. That means these are all nice, perfect squares. And if you don't know this length of something, we just call it x. So all of these values are x. All right. And then it says folding them up, resulting the flaps to form the sides of the planter, and then soldering, soldering, basically welding the four vertical edges. And then part C is asking what is the maximum possible volume? And then we're going to round to the nearest whole number. But to do that, I need to produce a volume equation. Now, I can't just say 20 times 60 because that'd be area. I have to have the x involved, which is the length, so or the height of it. So we don't know what the height is, but we can call it x. So the height is x times the length and the width. Now it's not going to be 20 anymore because I cut these squares. So this will actually become 20 minus, I have two x's. So whatever those x's were, let's say they're just 1 inch, I would then say 20 minus 2. So this is now 18 inches if that was the case. Now I don't know. So I write it as 20 minus 2x. And then same concept with the length of the sheet. This will then become 60 minus 2x. So then I have now length times width times height of 60 minus 2x. Now, because the problem here in your homework is just asking what's the maximum, I wouldn't even stress about multiplying these out. What I would do instead is let's write this into our type these into our calculators. So I just want to do a new screen share. All right, make sure y'all can see this. And there it goes. Okay. All right, so here all I'm going to do is go to graph, and I'm just going to type what I just wrote. So in this case, that'd be x. You do need in these calculators to put the multiplication sign. If you put x and then parentheses, for some reason these calculators do not recognize that that means to multiply. So then parentheses, 20 minus 2x. This part, a lot of students will go, well, what comes first, the 20 or the 60? That part, it really doesn't matter. And then this would be 60 minus 2x. And then when I hit graph, I might not be able to see it. So what I'll do is I'll hit menu over here, and I'll do window, and then I'll zoom out. And I like to put the zoom button right here in the center. So when I'm zooming, I can kind of see where I'm at. I think that somewhere over here. So I'm actually going to now switch to zoom in, and I'm going to see what's going on over here. So I can drag it. All right, let's try this one. Window. Let's zoom fits. Interesting. All right, so in this case here, we have to note that x, the maximum x can be is 20. Sorry, not 20, is 10. Since the length of it is 20, I can only cut up to 10. Now, granted, if I did that, I wouldn't have a base anymore. So with that said, since I'm seeing it go straight up, I just need to figure out what it is at 10. So that's the max my x is. So again, if I plug in 10 here, 2 times 10 is 20, and then I would get 0. So then I get a volume of 0, so that's unrealistic. So it has to be from 10 on. So what I'll do is I'll actually do menu 5 1. I'll turn trace on, and I'm just going to type the number 10. And when I do that, I automatically get 0. And then I can kind of see, oh, look, there it is right there. So I might not have seen it earlier, but there is a max right there. So I wonder if I can zoom in and actually see it. And it's not going to let me see it. But I'll definitely do that trace back on. And so I can see that there is a maximum. Maybe if I go back to standard, because now I'm really intrigued. See, I felt like there was one. See, now I'm just going too much. So zoom, standard, zoom, out. It definitely happens somewhere right there. So when I do menu 5 1, All right, well, I'll go back to the fit. And I know it happens somewhere right here by doing menu 5 1. And maybe you didn't know about the 10 thing. You can see that it hits 0 there. So you can kind of go, all right, well, if 0's here, it has to be somewhere in this direction. And what you can do from there is, again, hit that 10. But now it won't tell me like it did a while ago. I want to tell you what then. Let's see if we can do this. There's another one. So menu, I want to analyze the graph and I want to find a max. I know there's a max somewhere from here to here. So I'll go here and then I'll go here. Oh no, I don't want to go past 10. All right, so let's try that again. So analyze, we'll do max here to 10. And there it is right there. So I can see that my max value would be at 4.514 and it happens to be 2525. So that would be your answer you would come back over here with. So the max volume then is 25 centimeters cubed. All right, so again, that's the best way I know how to do it. I was trying to do it by hand earlier, and I was like, man, this is like a whole page for one question. I was like, that's what the book teaches. And the book actually says, using technology, now you can do this. And I was like, oh, okay, well, we'll go that route. But, and that's all you have to do. Again, playing around with that inspire to figure out where that maximum is. And again, the reason the domain here is actually, I wouldn't actually want it to equal 0 or 10 because then I would have no volume. But it can go all the way up to or down to 0 or up to 10, but not including those. And it would be some type of volume, just might not be a good one. All right, so let's look at another one. Let's look at 3C. On this one here, it says a car dealership wants to try out a new leasing arrangement, which will allow a buyer to trade a car back in the dealer to the dealership for a certain amount of credit at any time throughout the first 3 years of ownership. For a car in good condition, the time throughout the first 3 years of ownership. For a car in good condition, oh my bad, I just read that twice. For a car in good condition, the arrangement will value the car at 1/3 the original price at the end of 3 years and will depreciate the value of the car linearly over the course of 3 years. So let's talk about how this is actually processed. So the value of my car we'll call V at 0 years is full price and we'll call it P. After 3 years, it's saying that they'll value the car at 1/3 the original price. All right. So there you go. So that's all we know. So we can use this to produce a rate, right? Basically our slope. So this is your X, this will be your Y. So this would be P minus 1/3 P over 0 minus 3. So then I see P minus 1/3 of a P would be 2/3 P over -3. If you keep change flips, so keep change flip, I'm going to keep the first fraction, that's 2P over 3 times, and I'm going to flip this fraction, that's 1 over -3. And so then I would get negative 2P over 9. So this would be my rate. So every year I'm depreciating -2/9 of the overall price. Then from that, to produce an equation over time, because we need this to be able to answer C, we need the equation. So to be able to do the over time, we can say the original price, whatever it is, minus 2/9 of the original price, whatever that is, for each year. So 1 year, it would be 2/9 of the price. 2 years would be 4/9 of the price. And then it would keep going that direction. And this looks a little complicated. So some people will pull out that P and just say 1 minus 2/9 T, and that's completely up to you. I'm good either way here. So now, though, I'm able to figure out what the question to 1 is, and I'm going to use my original one here. I'm going to say P because it says, yeah, what is it after the first year? So I'm going to do P minus 2/9 P times 1. So that's this P minus 2/9 P, which would then just be 7/9 P. So after 1 year, my car will be valued 7/9 of its overall average, or what the original price are. All right. So let's look at another one. Let's look at 8C. All right, so 8C says, how much weight would the 5'6" tall person from part B need to gain or lose to have the BMI 22? So I actually have to do A and B to be able to do C, or really part of B to be able to do C. First, on part A, I need to be able to pull the equation for BMI. Now, we technically just did this in our last section. But it gives us the same information. So we're going to find a model for body mass index, or BMI, of a person given that BMI varies, so there's my equal sign, K, directly, so it's multiplication, as a person's weight, and inversely, so that means division, of the square of the person's height in inches. So there's the equation that you had to do in A that we did in the last section. Then we need part B to produce that K. So with the additional information, it says that a 6 foot tall person, so that's going to be 72 squared, because that's what how many inches 6 foot is, weighing 175 pounds, so I don't know K, so 175, has a BMI of 23.73. So to solve this out, I'm going to use a handy dandy little calculator. And so this would be 72 times 72. And then I'm going to multiply. So that's this right here gives me 5,184. So I'll multiply both sides by that. So then I'll take that and multiply it by 23.73. And I would get 123,000. 16.32 equals K times 175. So then I'll divide by 175. So then I'll do this divided by 175, and I get 702 0.9504 as my K. Now I don't have to finish the rest of the problem on, so there's my formula, there's my K of part B, but then I can use that now to help me with part C, the original question. So how much weight would the 5'6" person, so okay, so now we know our K, and we're trying to find out what the weight is. And she's 5'6", so that's 60 plus 6, so that's 66 squared. Need to gain or lose, so they have a BMI of 22. So now I can solve for W. All right, so that's going to be 66 times 66, which is 4,356, so 4,356. Multiply that by both sides. And so now what I'll do is I'm going to multiply that by 22, and I get 95,832 equals 702.9504. And then now I'll divide that. So then I get my weight must be then, so divide 702.9504. I must weigh 136.3 pounds, 136.3 pounds. Oh, okay, so that's how much they need to be. So if I go back and I look at the original weight, she originally weighed 140 pounds. So therefore, she would need to lose, was that 3.7 pounds? So she needs to lose 3.7 pounds to get a BMI of 22. All righty. So that's just questions that you would see. The rest of them are pretty much oh wait, no, man. There's one more. Then the rest of them are kind of using a table. So I'll kind of teach you how to use that as well. So looking at number 14 though first, it says Restaurante Caro frequently offers a special price fixed meal and has been charging $150 per person for the event. At that price, they've been averaging 30 customers each time. Their marketing firm has convinced them they'll gain a customer for every dollar they lower the cost of the event, and conversely lose a customer for every dollar they raise the cost. So their fixed cost per event is about $1,500, and preparing each customer's meal costs an additional $20. And I just want to do part B here, which is what are the break-even points in terms of the customer served. But to do that, I kind of need to know what the profit formula is. And to find the profit, I need to know what the cost and revenue formula. So I have to do part A. So pretty much I'm going to start with the cost formula. So it costs $1,500 regardless, and then plus $20 per customer. So that'd be 20x if you don't know how many customers you have. And then from that, to find the revenue, if it costs, if they get on average 30 customers and it goes up a dollar and down a dollar, then what I can do is I can say, all right, well, if I have 180 minus X, so let's say that's 30, that would give me 150, and then I would multiply that by 30, because each price costs $150 per person. They charge $150 per person. So to get a revenue one, adjusting going up and down per dollar. So if I have 31, this will go down, but this will go up. And so that's kind of helping us determine, all right, how much money will I gain and lose? So this right here is your revenue. Your profit is going to be your revenue minus what it costs. So in this case, that would be, if we go ahead and distribute that, that would be negative x squared plus 180x. So distribute that out. So I get negative x squared plus 180x, and then minus my costs. So that's going to be minus 1500 minus 20x. Combine like terms, that'd be negative x squared plus 160x minus 1500. You could type this in the calculator to find the break-even points. I think it's just as easy to find it. Break-even points just mean that it's set equal to 0. When did you lose? So sorry, when did you not lose or gain? Basically, if I have this many customers, I will make no money and I won't lose any money. So in this case, what I'm going to do is I'm actually going to multiply everything by negative. I guess it doesn't really matter. I'm going to use the formula negative b plus or minus the square root of b squared minus 4ac, all divided by 2a, which is the quadratic formula. So this is negative 160 plus or minus 160 squared minus 4 times negative 1 times negative 1500 divided by 2 times negative 1. So I get negative 160 plus or minus 160 times 160 is 25,600. Positive then negative. So this would be negative 1,500 times 4. So that's 6,000 over negative 2. So I get negative 160 plus or minus 25,600 minus 6,000. So that's 19,600 divided by negative 2. And curious, does that give me a perfect square? It does. So that's going to be negative 160 plus or minus 140 over negative 2. So when I break these up into two parts, this is negative 160 plus 140 divided by negative 2. And this is negative 160 minus 140 divided by negative 2. So this will give me negative 20 divided by negative 2. So that's 10 customers. And this would be negative 300 divided by negative 2, which is 150. So I have a break even between 10 and 150 customers. So basically, as long as I have more than 10 but less than 150 customers using this model, I will make some type of profit. Okay. All right, so then the next question or questions are pretty much all tables. So I'm going to kind of do like one, but really I might do a second one, but they're pretty much all the same. So looking at number 16, it's asking me to use the table from the notes in table 1 or in your section, and then to answer those questions. So what I'm going to do is I'm going to screen share the calculator again. Let's see, make sure you can see it. Yes, perfect. All right, so from here, I'm just going to go home. I'm going to go to my list and spreadsheets, and then I'm going to let this column be X and let this column be Y. And then I'm going to type that long table. So that's going to be on page 296. So we will illustrate the key ideas for this example from 1950 to 2010. All right, so here we go. So that's going to be 1790. Oh, 1800s. And it looks like it's going by 10. So 1810, 1820, 1830, 1840, 1850, 1860, 1870, 1880, 1890, 1900, 1910, 1920s, 1930s, 1940s, 1940s, 1950s, 1960, 1970, 1980, 1990, 2000, and 2010. All right, so now I come back to the Y's and now I got to type all those numbers in. That's going to be a lot slower of a process. So 3929, 214, 5308, 483, 7239, 881, 9638, 453, 12, 860, 702, 17, 063, 353, 23, 191, 876, 31, 443, 321, 38, 558, 371, 50, 189, 209, 62, 979, 766, 76, 212, 168, 92, 228, 496, 106, 021, 537, 123, 202, 624, 132, 164, 569, 151, 325, 798, 179, 323, 175, 203, 302, 031, 226, 542, 199, 248, 709, 873, 281, 421, 906, 308, 745, 538. They started looking like phone numbers there at the end. All right. Then from there, then we go to home and then to data and spreadsheet statistics. Let the bottom be X. Let the left be Y. So then here is our nice, beautiful data. And so now we can answer all the questions. The hard work's just entering in there. But part A says, how do you interpolate the population for 1955 compared to the two models? All right, use the linear and quadratic functions. Sorry, so then to do that first, we go to analyze, we'll go to regression. They want a linear model, and we'll do menu, analyze, regression, quadratic. And so there is a quadratic. I'll put it right here. And then we have a linear as well. If I just click on that one, I can pull it up right there. So I wonder if I can just go back and forth. There we go. So there's my two. And we want to know how do we interpret it the 1955. I wish there was a way to copy that. Ooh, there is. Graph trace. So I'll turn on trace and I'll just go to 1955. Oh, okay. Hold on. I just got to go to, oh, well, there it is right there. Kind of. Hold on. Let's see. So I go back to this one. Doesn't let me type. That's unfortunate. So I want to know the exact answer. All right, so let's do this real quick. Sorry, escape. What if I just hit delete? Ah, here we go. All right, let's try that again. So we'll do we'll hit this, and then from that I want to all right, from this one I want to graph trace. If I do 1955, it doesn't do anything for me. So I need to go find right there. So I get 1.7. Ah, so 1.78. And then here's about 1.08. So we can see that they're about average, a little off a little bit. And that's really all you have to do there. The other way to do that is to take these, and I wish you could just copy them, but you would need to escape, I guess, for starters. There you go. And I wish I could just like copy and paste it, because that's really what you need to do to be able to answer the question thoroughly. But then part B just says, what is the extrapolated linear model population for the year 1800? So basically, I just need to come over here to 1800. So again, graph trace. So 1800 is about 5,308,000. And then the other one, I can't even get to 1800 because it goes into the negatives. So when I look at and that's what it asked me to do, is look at the linear one. So I get negative values. So therefore, that can't be realistic. So I wouldn't want to use the linear one to predict back in the day. Then part C is like, what is the calculated quadratic model at 1800, which is what I looked at first. And that's about, oh, there it goes right there. So 1800 was 55,308,483. And when you look at the US Census, it was actually 5.93. Basically what that would be, that was, what was that, 5,930,000. So that's pretty close and accurate. Then part D goes, now imagine tracing this quadratic back in time before the US actually existed. What is the extrapolate model in the population 1000? So if I wanted to, I don't think it's going to let me go any further, but if I go into the thousands, I'm probably going to go back up here. And if you actually take this equation, this one right here, and actually plug in 1,000, you will actually get 4,340,000, which is unrealistic because that's about the same in 1980. And so then that wouldn't be realistic. You wouldn't have that many people, and then we go down and go back up. So sometimes it can be used pretty well, and then sometimes not so much. The next question is the same thing, plugging it in and then finding the linear and quadratic equations and then representing those. I'm not going to make you do that again, but if you need me to show you another example, just let me know. Other than that, that's all I have for this. Always email me if you have questions, and then I'll see you in the next video. Bye for now.